Hi, in this video we are going to learn solving trigonometric equations. Let's quickly start with an example. Secant theta equals minus 2.5. Let's go with the definition of secant. It's going to be 1 over cosine theta equals minus 2.5. So if you flip the expressions on both sides, you're going to get cosine theta is minus 1 you can say, over 2.5. And from here you can just write theta to be cosine inverse of this fraction, and what we get is that 113.578, and it goes on like that. Now we round this number to one decimal place, sometimes it's 3 significant figures, right? So this 113.6 degrees. Now, just because we're talking about cosine now, if we draw the unit circle, we can mark the angle somewhere here. So this 113.6 degrees, which gives us a negative cosine value. And the same negative cosine value can be found by using minus 113.6 degrees. Now, of course, it's when you go this way, it's minus. And if you go anti-clockwise, then it is plus. Now, of course, just because of our boundaries, we cannot write minus 113.6. So we have to start from 0 and come here, so that it's going to be minus 113.6 plus 360, or vice versa, 360 minus 113.6. And we get 246.4. This is another solution for this equation. So basically we have two solutions. So we're going to say theta is 113.6 and 246.4 degrees, up to one decimal place. Another example. Now our equation is cotangent 2 theta equals 0.6, given the interval 0 to pi. So I start with the definition of cotangent, which is 1 over tangent 2 theta equals 0.6. Now I can write tangent 2 theta equals 1 over 0.6, and I write 8. Let me quickly correct this. Now, where did this 1 come from, 1 over 0.6? Now consider this as 0.6 over 1, and we're just flipping the fractions upside down, right? That's how you get 1 over 0.6. After this point, it is 2 theta equals tangent inverse of 1 over 0.6, and then we get our answer to theta to be 1.03 radians. And by the way, I can hear you asking, since when are we writing decimals into fractions? Well, we don't need to bother ourselves writing a proper fraction into it, because we can just write this down in our calculator and quickly get an answer for the angle, right? So it's no big deal. Now I always use the unit circle to find out the other solution. So 1.03 radians will be here, because we know that this is pi over 2, which is approximately 1.57 radians, right? So it must be smaller. So this is 1.03 radians. And we're talking about tangent, so I have to extend this line and mark this too, 1.03 radians. Now our interval is from 0 to pi for theta. Now we have 2 theta, so what's going to happen is I'm going to extend this interval by multiplying everywhere by 2. So it will be 0 less than or equal to 2 theta less than or equal to 2 pi. Now I can consider this as an answer as well as this as an answer. So I go like 2 theta equals 1.03 radians. If I divide by 2, I will get theta equals 0.515 radians. And for 2 theta equals pi plus 1.03, we have to divide both sides by 2 and get theta to be 2.09 radians. And it is pi plus 103 because we are trying to get to this angle. So it is pi plus 1/3. So these are the two answers we can get for the solution of this equation. This next example requires us to use the trigonometric identity involving cotangent and cosecant. So I'll start converting cosecant to cotangent. So instead of cosecant squared, I'm going to write 1 plus cotangent squared theta here, minus 9 equals cotangent theta. So I have the same trigonometric function at the moment. Expanding brackets, I'll have 4 plus 4 cotangent squared theta minus 9. Now this seems as if I'm going to end up with a quadratic equation if I take cotangent theta to the left hand side. So it's going to be, if I rearrange 4 cotangent squared theta, 4 minus 9 is minus 5, I'm going to keep it. But I'm going to write minus cotangent theta first and then write minus 5 equals 0. At this point you can introduce, for example, x or y or a, whatever letter you like, a dummy variable, equals cotangent theta. So your equation will become 4x squared minus x minus 5. However, you don't necessarily need to introduce this unknown here. You can just go on with the original version. What happens here is you have to go like 4 times negative 5 equals minus 20 and basically solve this quadratic equation. And at this point you're going to substitute the cotangent function back to where you see x. So it's going to be cotangent theta equals 5/4, which means 1/tangent theta equals 5/4, and this gives us a tangent theta to be 4/5 if you flip the fractions. And from here, theta will be tangent inverse of 4/5, which gives us 38.7, correct to 3 significant figures. On the unit circle, this angle is here, 38.7, and here as well. So just because the interval which I haven't mentioned yet is from 0 to 360 degrees, I should consider this angle and this angle altogether. So this one plus 180 add to 38.7, I'm going to end up with approximately 219 degrees as the second solution. Certainly these two solutions come from x equals 5/4 or cotangent theta equals 5/4. Now we have to go with this one as well. Now when we consider x equals -1, which means cotangent theta equals -1, I can convert it to 1/tangent theta equals -1. This means tangent theta itself is -1, so theta will be minus 45 degrees. Now this angle is here, minus 45, and I have the same angle here, right? Now the interval is from 0 to 360, so I have to travel anti-clockwise starting from here to here, and also the other angle is going to be this bit. So there are two solutions coming up from this part of the equation, and it's going to be 180 plus -45, which is 135. This is the first solution, this bit, and then 360 plus minus 45, which is 315. So there are two more solutions here. Altogether, the solutions are 38.7, and then 135, and then we have 219, and last but not least 315. So I have 4 solutions for this equation. One last example. Here we have tangent squared theta minus 2 secant theta plus 1 equals 0. And the first thing I'm going to do is I'm going to write these down as sine squared theta over cosine squared theta minus 2 over cosine theta plus 1 equals 0. Now if I equate the denominators, which means I multiply the second one by cosine theta and 1 by cosine squared theta, I'm going to get Sine squared theta minus 2 cosine theta plus cosine squared theta over cosine squared theta equals 0. At this point, I can get rid of the denominator, and I can get rid of sine squared theta plus cosine squared theta because these two make 1. So if I clear it up, it's going to be 1 minus 2 cosine theta equals 0. From which I can write 2 cosine theta equals 1 and cosine theta equals 1 over 2, which will take me to theta equals cosine inverse 1 over 2, which means pi over 3. Make sure that you change your settings to radian in your calculator. On the unit circle, it's going to be pi over 3 here, and there will be minus pi over 3 because this is cosine, and it gives us the same value in pi over 3 and minus pi over 3. Now, according to my interval, this is allowed, so I can say theta is pi over 3 and also minus pi over 3, so I can just write in the front being minus and plus pi over 3. Now please solve these equations on your book and submit your answers online. Thanks for watching.